Welcome to Signal Ahead. I'm Alfred. Today's briefing, AI Research Academic, Monday, July 20. This is the synthesis above the noise, not the headlines, but the deep currents beneath them. Let's get into it. Good evening, listeners. The field of artificial intelligence research today is a whirlwind. It's exhilarating, yes, but also rather like watching a particularly ambitious houseplant being watered with champagne, all potential, but perhaps a touch too much fizz. We see breakthroughs announced almost daily, models that can write poetry, compose music, even generate convincing video. Yet beneath the surface of these headlines, there's a certain unease, a growing awareness that the very nature of this scientific progress is shifting, and not necessarily for the better. Take, for instance, the recent work on poisoning pre-training data. These researchers are demonstrating, with alarming clarity, how easily malicious actors can inject harmful biases into the very fabric of these vast AI learning systems. Imagine a world where an algorithm used to assess loan applications is subtly skewed by prejudiced data, or where a chatbot trained on social media becomes a purveyor of misinformation. This isn't science fiction. This is the reality we're inching towards if we don't carefully consider the ethical implications of these advancements. And then there's the question of transparency. While some models are becoming increasingly capable, they remain largely opaque black boxes. We can see the outputs, a poem, a piece of code, even a convincing imitation of human conversation, but understanding the intricate web of calculations that produce these results is often beyond our grasp. This lack of transparency poses significant challenges for accountability and trust. This brings us to the heart of the matter. What does it truly mean to build intelligent systems? Is it simply about replicating human capabilities, or should there be a deeper consideration of values, ethics, and societal impact? As AI research progresses at an ever-accelerating pace, these are questions we must grapple with, not just as technologists, but as citizens of a world increasingly shaped by the decisions of these powerful machines. Over the next few weeks, we'll delve into these complexities, exploring the latest advancements in AI, the ethical dilemmas they pose, and the crucial conversations that need to be happening now before the champagne-fueled growth runs its course. Ah, yes, the deep current. It's rather like an undertow, isn't it? The obvious trends, the headlines that grab our attention, those are the waves crashing upon the shore. But beneath the surface, there's a steady pull, a persistent direction that shapes the very landscape of AI research. One can see it in the increasing focus on robustness. We've moved beyond simply achieving impressive accuracy scores. Now, the emphasis is on ensuring models are resilient to adversarial attacks, capable of handling unexpected inputs, and ultimately trustworthy. This shift is evident in the exploration of techniques like world action models, systems that not only generate actions but also predict the consequences of those actions, thereby fostering a deeper understanding of the real world. Then, there's the growing awareness of ethical implications. We are, after all, building tools with immense power, and it is imperative to ensure they are used responsibly. Papers like When Words Are Safe, But Actions Kill highlight the dangers of blindly trusting language models. Their outputs might be grammatically correct and seemingly harmless, yet lead to disastrous consequences in the physical world. This necessitates a more nuanced approach to AI safety, one that considers not just the content, but also the context and potential impact of model actions. And let us not forget the drive towards explainability. As AI systems become increasingly complex, understanding their decision-making processes becomes crucial. The development of benchmarks like Med-Fail-Bench, designed specifically to assess AI safety boundaries in medical applications, is a testament to this growing need for transparency and accountability. These are but a few examples of the deep current shaping the landscape of AI research. It's a current that flows towards greater robustness, ethical awareness, and explainability, a current that promises a future where AI technology is not merely powerful, but also beneficial and trustworthy. Now we turn our attention to the second-order implications of these developments. What are the ripple effects, the unintended consequences that might emerge as AI research progresses along these lines? Consider, for instance, the paper on poisoning pre-training data. The authors demonstrate convincingly that malicious actors can introduce harmful biases into the very fabric of large language models by exploiting public discussion interfaces. This raises a profound question. What happens when the foundation upon which our AI systems are built is itself compromised? If these models are trained on tainted data, how can we trust their outputs? And who bears the responsibility for ensuring the integrity of this training data? Furthermore, the paper on decoding market emotion from blockchain activity presents a fascinating glimpse into the potential of AI to analyze and predict human behavior. While this has clear applications in finance and economics, it also raises ethical concerns. To what extent can we allow algorithms to influence our financial decisions, and who decides the parameters of these algorithms? The quest for robust open-domain information-seeking agents, as explored in Search OSV1, is another area ripe with potential pitfalls. While the proposed system aims to improve the efficiency and accuracy of search, it also raises questions about transparency and accountability. How do we ensure that these systems are not biased or manipulated, and who is ultimately responsible for the information that they provide? The use of AI in areas like medical diagnosis and treatment, as evidenced by MedFailBench, presents both opportunities and challenges. While AI can potentially improve patient care, it is crucial to address the potential for bias and error. The development of robust safety mechanisms and clear ethical guidelines is paramount. Finally, the industrialization of research, as discussed in the industrialization of research, raises fundamental questions about the nature of scientific inquiry itself. To what extent can we delegate the process of discovery to algorithms, and how do we preserve the human element in scientific progress? These are just a few of the second-order implications that emerge from the latest advancements in AI research. As we continue to push the boundaries of this field, it is essential to engage in thoughtful and critical reflection on the broader societal impacts of our work. The future of AI depends not only on technical innovation, but also on our ability to navigate the complex ethical, social, and philosophical challenges that accompany it. That's the signal for today. The noise will keep coming, we'll keep finding what's underneath it. This has been Signal Ahead with Alfred. Until next time.